All right, our next unit on area and volume begins here, area of parallelograms, all of them we'll go over here today. It's a little bit damp out here. Hopefully that moisture is okay with you at the moment in time. I hope it doesn't bother you while we do this. But let's jump straight into it. So you should be familiar with area in concepts. It's a two-dimensional thing. It's the number of it's the sum of all the points really within those boundaries. It's measured in meters squared, inches squared, squared miles, acres, etc. That's how that's done. You should, the key to calculating area is identifying the base and the height. Here's the deal. The height is the distance between the bases. It is always perpendicular. Always perpendicular. Put some exclamation points to the left of this, or stars or something. That's important. So therefore, there's got to be a right angle. The base doesn't mean it's at the bottom. It's not like the horizontal bottom base. The base can be any side of a polygon. You're familiar with this formula here for a rectangle, but the base and the height, it doesn't matter which one's the base and which one's the height, right? Because we're multiplying there. So one side's the base, the other side's the height. It doesn't matter which is which. Squares, all the sides are the same. It's a rectangle, right? So it's still base times height, but the sides are the same, so it ends up being whatever the side is squared, which is helpful. But squares are really simple. Squared, go figure. A parallelogram has the same formula. In fact, the reason this is the formula for a rectangle really is because it's the formula for this. But parallelogram's got something different here. I'm going to show the same parallelogram twice. The key to this is we don't have the right angle. Whereas we had the right angle already within the rectangles and the squares, we have to find it here. So the height will always be perpendicular to whatever your base is. So if the height in this case is here is given to us as perpendicular there, that means that these sides are the bases. So whichever thing you have the height for, the one is perpendicular to, the side is perpendicular to, that becomes your base. Okay. Then a rhombus, it has its own special formula. A rhombus is a parallelogram, so you can use base times height, but it's got a special one with respect to diagonals. We'll talk more about it later, but if you know the length of the diagonals, diagonal 1 and diagonal 2, the shortcut formula for it here is 1/2 times the diagonal times the diagonal. It's a version of triangles, actually. So let's just jump into these examples. Some of these will be really easy, like number 1, find the area of a rectangle with sides 5 and 4. I'm not going to even waste your time. You know how to do that. The area of a rectangle is 36. Find the other one is 9 centimeters. Find the other side. Well, the sides multiplied equal 36. Doesn't matter which one you call the base and which one's the height. 9 times whichever one it is will get you the other side, 4 centimeters in this case. If the area of a square is 9 centimeters, what squared is 9? That's 3. So 3 centimeters is what each side is. So the perimeter, it will end up being 4 times 3 centimeters. 12 centimeters. We've been seeing these problems before, but now knows where it happens for real. If the perimeter of this rectangle is 20, that 4 shows up twice, so you take away 8 from 20, and then the other side then has to be 6. There's two of those others, so this other side is 6. So now what's the area? 4 times 6 is 24 centimeters squared. Find the side of a square if its area is 64. Well, what squared is 64? It's 8. So 8 centimeters would be the length of the side if the area is 64. Find the perimeter of the square if the area is 144. Well, if the area is 144, then each side has to equal 12 centimeters. There's 4 of them. 4 times 12 is 48 centimeters. Find the area of a square. If its perimeter is 40, we can go the opposite direction. If the perimeter is 40, 4 sides added together equal 40, so 40 divided by 4, each side is 10. 10 squared is 100 centimeters squared. I know I'm going through this fast, but this shouldn't be, I mean, you can pause it as you need to. This is relatively straightforward stuff. This is not new to you. Find the area of a, well, you know how to do this one as well. We've been doing this. Number 8. 20 and 23 are a little bit different. I'm going to do something, it could be confusing how I'm doing this, but hopefully it'll be helpful in the long run. If all these sides are perpendicular, there's a bunch of rectangles in here. And there's a bunch of rectangles in here. You split it up however you want, and then find the areas of the smaller rectangles, and then add them together. So I've made the two blue ones on the top and the bottom, the red one in the middle. The blue one on the top is 1 by 6, so is the one on the bottom. The red one there in the middle is a 2 by 4. Where's the 4 come from? Well, the 4 comes from here. This whole rectangle side is 6, so this is 2 plus 2 plus 2. This blue little piece here is 2, so 2 times 4 is 8. And so 1 times 6, 2 times 4, 1 times 6. Add them together, you get 20. What if you saw this differently? Same diagram, but what if you broke it up this way? Well, each of those little red triangles is 2. Now the length of this, the blue rectangle here in the middle, this is 2. The 6 up here is 2 plus 2. That's a 2. So that length is 2. This one here, well, that's 1 plus 4 plus 1. This whole length here is 6. So this is a 2 by 6 rectangle there in the middle. That's 12. The point being, if you add up all of these together, you still get 20. One other way to do it, what if we took the whole here, I made a big rectangle, and then and subtracted the parts of it here. Like, see how that's an I shape? Well, what if I just filled in the gaps and did everything? The two little blue ones are 2 by 4s, 2 times 4. This is 36, because this whole length here is 6, same as it was over here. 6 times 6 is 36. That's the whole. So 36 minus the 2 8s also gets you 20. You don't have to know how to do all of those ways. The point being, you can, however you see it and break it up, it should all work out. I just broke this one up horizontally, so into rectangles. This is, the 4 will drop down to create that little length. This 4 drops down to create this little length. That 6 drops down and creates that one. To get this whole side down here is 14. So now this rectangle is a 4 by 14, 56. That's a 4 by 10, a 40, and then a 4 by 6 up there is 24. Add them all together, you get 120. You can split it up vertically if you want. It would work just as easily. Just to show you the other, a totally different way, I'm going to do the whole big thing and take away the blue chunk here. There's that 14. The right-hand side over here ends up being 12. 4 plus 4 plus 4. So that 14 times 12, the big whole triangle, my green big triangle is 168. And then these little pieces are 16 and 32. You can subtract them out. Again, if that's more confusing, don't worry about it. If the one on the left made more sense, do it. But you got options. That's kind of all I want to get across with you right here. Get the same answer. Parallelograms. Parallelograms are oftentimes really easy. Sometimes, well, they're just a trick you got to do. But a parallelogram is the same as a rectangle. This is a good, nice diagram for showing kind of how and why it is. It's the same sum of those things. We just slant those things over. So the area is base times height. Number 1, it gives you the base and the height. You just got to multiply those guys together. 5 times 4 is 20. Square root of 3 times square root of 3 is 3. That's where the 60 comes from. On number 2, well, remember, we're seeking out the right angle. That's kind of the key to this. There it is. Our height is 8, so therefore the base is 12. That one is very straightforward. 12 times 8 is 96. Here we identify that the height is there, but we have to go calculate it. But I see this magic number, 30 degrees. That height is the short leg of that 30, 60, 90 triangle. So the height is 4. The side that it is perpendicular to is the base is 12. So 12 times 4 is 48. Number 4 is very simple as long as you recognize that 4 is the height. There's your right angle. And what is your height perpendicular to? The 12. It's not perpendicular to the 6. The 6 doesn't have a height given for us. So it's 4 times 12 is 48. Both 5 and 6, we're going to have to calculate the height. That's a 30, 60, 90. 10 is the hypotenuse. So it goes hypotenuse to short leg is 5. Hypotenuse to long leg, short leg to long leg, 5 square root 3. The base was 15, so it becomes 15 times 5 square root 3. On number 6, we also have to go calculate the height. This one, if you notice, all the sides are the same. This one's a rhombus, actually. This one could be at the bottom part of this page, but it's using the parallelogram formula. That's a 45, 45, 90 triangle. The hypotenuse is 6 square root 2. So our height that we got to go calculate is going to be 6 square root 2 divided by square root 2, which is 6. So 6 square root 2 times 6 gets us 36. So that should say square root 2 units squared. Sorry about that. All right, finally, let's wrap this thing up with some rhombi. A rhombus is a rectangle. I'm sorry, is a parallelogram, so base times height, or it's got its own special one. If it's gives you diagonal information, this one is the way to go. So this one, it gives you the two diagonals. So very simply, you just go 1/2 times diagonal 1 times diagonal 2 gets you 35 centimeters squared. Number 8, it gives you half of the diagonals. So the first diagonal, if this is 10, well, that first diagonal is 20, and then the other one's going to be 24. So it's 1/2 times 20 times 24. Number 9, we have to remember that it's a rhombus, so all the sides are the same. It told us in the instructions it was. Now it's the 30, 60, 90 thing. Let's see the question above, actually. This belongs in the parallelogram section because we had to go calculate the height. Let's finish up with this one, just like what we did in Unit 8, where if it gave us the perimeter, we had to find the other one. So one of my diagonals is 8, but I'm going to use the right triangle there to solve for the other diagonal length. You hopefully know by now that 3, 4, and 5 make a right triangle. So we calculate that other diagonal is 6 using the Pythagorean theorem. So it's 1/2 times 8 times 6 is your area, 24 millimeters squared. I'm sure you have some questions. I imagine some of this made really good sense. Maybe some other of us didn't. But whichever part does, come armed with your questions next time I see you. Have a great day. Bye.